Imagine walking straight through a locked door. Sounds like sci-fi? Scientists just built a machine that essentially did exactly that. It's called quantum tunneling, and we thought only tiny electrons could do it. But the new Nobel laureates prove that giant clusters of billions of electrons can do it too.
So this year's Physics Prize is about putting quantum mechanics, which we know from the subatomic world of electrons and subatomic particles, onto such a chip, electrical circuit on a chip.
In classical physics, if you throw a ball at a solid wall and it doesn't have sufficient energy, it simply comes back. However, in the quantum world, particles behave like waves. They leak through a barrier like a ghost. This is quantum tunneling, a process where a particle tunnels its way through the impossible, even when no classical path exists. We usually witness this ghostly behavior in the world of microparticles like electrons and protons. But could something much larger, like a tennis ball or even a human, tunnel through a solid wall? 3 scientists, John Clarke, Michel Devoret, and John Martinis, decided to tackle this paradox. They were looking for exactly one thing: macroscopic quantum tunneling, forcing billions of electrons through a forbidden barrier like a ghost phasing through a solid wall. The key component was a Josephson junction. It's a simple setup: 2 superconductors separated by an insulating barrier. When they activated the circuit, the results were staggering. Current didn't stop at the barrier. It slipped right through as if the solid wall had simply vanished. This was a massive quantum leap, billions of electrons working together to defy the laws of classical physics. But the mystery went even deeper. When they shot microwaves at it, it acted exactly like a single microscopic particle. They had engineered a giant, man-made superatom that follows the strange and impossible laws of quantum mechanics. This breakthrough raises a mind-bending question.
Macroscopic system could be my entire body. Could I walk through a wall?
What happens is, if you look at an electrical circuit, then the parameters become favorable for seeing this kind of macroscopic behavior. And okay, it's hard to go into the whole physics of all that.
Human beings cannot tunnel through a solid wall due to decoherence, a process where environmental interactions disrupt the delicate superposition of large systems and forcing them to behave classically. However, this technological breakthrough ignited the race for commercial quantum computing. Companies like IBM, Google, and Rigetti are using this Nobel-recognized technology to scale up the world's most powerful quantum computers. These machines will soon help us solve puzzles that have baffled scientists for centuries. Finally, if you enjoyed this video, here is a small request. Subscribe to our channel to catch all the latest space discoveries and exciting updates. Thanks for watching. See you in the next video.